Hello everyone, you are welcome to the last part of the series involved in transformation of data using Python. Now in this particular video we shall be looking at normalization. So we are talking about how to normalize a data set. Now normalization is a statistical term that is used to adjust the data points across the features of the data such that there is an equal distribution of the data around the mean value. So you have a range of data and then you get the mean. So when a data is normalized, that is when the data set, the data point, is evenly distributed. So that means, let's say you have children in the class, just as I gave in the last video. You have children in the class ages 3 to 6, and then the mean is expected to be what? To be 4.5. So if that particular distribution is normal, then half of the class is meant to be on one side of the mean value, and then the remaining half should be on the other side of the mean value, meaning from 3 to 4.49 is expected to be possibly on the left, and then from 4.51 down to 6 is expected to be on the right. That is a normal distribution. So in normal distribution, the mean, the median, they fall in the same line, and even the 50th%. Let's look at this. Now this is normalization in diagram. Now when you look at the data, you can see where the arrow is facing. That is a normal distribution. So this particular data set is evenly distributed. Now when you look at the vertical line and the horizontal line, please, which is actually the x-axis, you will discover that the starting point from the left is -10, and then the ending on the right is +10. So this is a normal distribution. Now this is not obtainable in our everyday data set, so that is why we are going to be normalizing the data in this particular project. So let's go into our notebook. Okay, so the first thing we want to do is we want to check out the column of the original data. Okay, we have the columns already. Now let's look at let's try to picture the pregnancy column. Okay, so now you can see, so this particular column is skewed to the left hand side. You can see in the middle is supposed to fall in somewhere here, from this point, but you can see where it falls. That means there are more values between 0 and 5 and 10. There are more of these values than other values, so that is why it is like this. So this particular distribution is not normally distributed. So because of that, we are going to normalize the data. Now normalization. Okay, we'll change this to a markdown, then we'll run. Okay, so the first thing we want to do is to call in the constructor, the normalization constructor. Calling the normalization constructor. Okay, so say from sklearn dot pre-processing import normalizer. Okay, so since we've imported it, now we are going to now create the values. Now remember, in this last one what we used was this, so we are still going to be using this particular okay, and then we want the array form, so we are changing it to array. Now we'll say, and then dot values. Of course, dot values changes the data frame into an array. Now we want the input variable or the input feature to be x, so we'll call this rescaled xdf underscore r underscore s. Okay, so we want all the rows and then the 7 columns, and then this is output variable. So we want all the rows and only the 8th column. Now we'll run this. Okay, slicer no, slicer 08. Now let's see where we have the challenge. Invalid index error. Okay, so I guess I did a mistake here. I was calling out the data frame instead of the array, so I was supposed to put r here, and then I was supposed to put r. Okay, I'll take this away and then I'll run. Okay, so now since we have done that, now we are going to fit and transform. So it's just in normalization is just similar to that of the standardization, in which you can fit before you now transform. So we are fitting in the x, so we'll call this normalizer is equal to normalizer dot fit x. So you can see it, so x is the input variable, so we are fitting it, and then since we are now fitting it, then we'll now call this normalize x df is equal to normalizer dot transform. And then what are we transforming? We're transforming x. So So we'll set our print option. Please don't forget, you always set your print option. That is it's actually your choice. Precision equals 3, and then want to print normalized xdf. Oh, let's see. Yep, that is it. So our data has now been normalized and it has been transformed totally. Now we want to change the data into a data frame. And in changing this data, we'll call it normalized data frame. Normalize, yes, this should be data frame equals pd dot data frame open bracket. Okay, so the data that we are using is normalized xdf, and then the columns that we are talking about, so we are involving in this. Let's bring them out. So these are all the columns. We'll just pick this and then we'll drag and drop. Can you see that? Okay, so since we have done that, then we'll now bring in the output feature, which is y. So now in bringing it out, we say normalized tf. Okay, we'll set the column to the outcome equals this normalize. We'll pick this because this was the data set we use in starting the normalization process. So it contains the outcome, and then we want it to print normalized df. Okay, with the edge, with the top records. So can you see that? So this data has successfully been transformed. Now let's look at the statistical property. Not df any longer, so this will be normalized. Let's confirm if it has described dot t. Okay, then we'll run this is shift plus enter. Okay, so what are we seeing here? So we are seeing, can you see the standard deviation? Okay, you can see they are all in zeros. You can see that 0.3, 0.3, 0.4. So that is how it's supposed to be, and then you can see the mean, and then you can see the 50th percentile, the 75th percentile, and then the maximum. So you can see the maximum is not more than 1. So these are processes involved in data transformation. So now let's try to visualize the pregnancy again. The pregnancy. Let's see if the data set is now distributed properly. Okay, yep, can you see that now? So you have 1.5 minus 1.5 here, minus 1.5, and then the middle I think is supposed to fall in somewhere here. You can see that. Okay, so this is a normalized normalized data set. You can also check in for other columns. Let's look at age. Normalized df dot age, okay, age. Sorry, I was thinking is a small letter a kind equals density. Okay, so you can see it too. So these, so 1.5 here, 1.5 here, and then this is the center. So this is how we transform our data using using Python. So I hope you have been able to learn something new today, and I actually am committed to your overall development as a data analyst. In the next series that I'm going to start using the same data, we shall be looking at how to build a model. Yes, how to build a model with this particular data set. So we want to build a model to find out, okay, we'll build a model based on this outcome to find out whether the patient has diabetes or not. So where 1 is the patient has diabetes and 0 the patient does not have diabetes. So we are going to go into machine learning in the next series. So until I see you next time, stay safe and happy learning. Bye.